Welcome everyone. It's good to see you today. We're going to be talking about carbohydrates part 1, basically their general daily intakes for endurance performance. So what we're going to do is, the primary purpose of today is going to be to determine carbohydrate needs and the effects of various carbohydrate diets on performance in aerobic sports. And remember, aerobics classified as more long duration events while using oxygen. So one of the things that you want to think about with carbohydrates is what is the impact of intensity and duration on both muscle and liver glycogen? And then also, what dose of carbohydrates do you need to replenish glycogen? Well, this is a real good study by Romjan, classic. In each of these conditions, you have a low intensity condition, which is LI, that's walking, moderate intensity, which is a jog, and then high intensity, which is more like a run, an intense run. The green is how much fat's used, and the blue is how much carbs are used. What you can notice is that at low intensities, you use very little carbohydrate. At high intensities, the preferred fuel source is carbohydrate. So the higher intensity you go, the greater your reliance on carbs are. Now look at this graph here. Okay, you have essentially on the x-axis you have time. This is a time to exhaustion trial. It's basically how long it takes before the person says, I'm going to quit. The very top line, the line that lasts the longest, is 31% of VO2 max, or low intensity. Well, obviously they're going to go the longest. If you notice, they barely use any glycogen, which is on the vertical axis. So they barely use any glycogen because they're so reliant on fat that essentially glycogen is not limiting at very low intensity conditions. However, if you look at the moderate condition and the high intensity condition here, notice that they went to exhaustion faster and that exhaustion was directly associated with a depletion of muscle glycogen levels. So at moderate to high intensities, glycogen does become limiting. Same thing with liver glycogen. This study showed that it took 4 hours to deplete liver glycogen with 40% VO2 max, but only 2 hours with 75% VO2 max. On the right, you can see essentially hepatic glucose production. And what are you noticing? You're noticing that at the higher intensities, hepatic glucose production is higher. So, one of the things to think about is how important, we know muscle glycogen is important, but how important is liver glycogen? This was a very cool study. If you look at the graph and look at B on the graph, what they did was they took 3 conditions, a placebo, an infused, and a feeding condition. But in basically these conditions, the first run was not consuming any food or being infused with anything. So they all went to fatigue at the same time point. And notice that when they fatigued, they were hypoglycemic, which is defined as plasma glucose levels of about 3 millimolars or less. So you see that they hit that threshold. Now, over in graph D, one thing that you see is you have the placebo condition, which is the very bottom condition. Notice that they went to exhaustion the fastest. Then you have the feeding condition. They ate carbs, took them longer to go to exhaustion. Then you have the infusion condition, which they infused glucose, and they lasted the longest. This is suggesting that their liver's ability to put out glucose is in part limiting to how long we can go. So as we train, you notice that athletes can go longer and longer distances. They can also recover faster and train at higher frequencies. Why? Well, if you look here, this is glycogen depletion. Here in untrained and trained people, 15 minutes after the bout. Notice that it's at 6 and 48 hours, you see greater glycogen supercompensation in the trained than untrained. And this is related to the what's called glucose 4 receptor content of the muscle. So glucose 4 receptors essentially are channels that allow the muscle to be permeable to glucose. So athletes have more of these. And so trained athletes have higher resting muscle glycogen than untrained. So an untrained person might have 80 millimolars per kilogram muscle wet weight. A trained person might have 120, 130 millimolars per kilogram of dry weight. One way I always think that's easy to remember is just imagine that on average you have 100 units of glycogen, and you're always looking to see how much of that's depleted. It's easier than like millimoles per kilogram. Now, again, trained people actually use more fat than untrained. So you can see that if you look at the black, that's fat oxidation. Trained people use more fat than untrained. So if we were to summarize this up, here's the bottom line, guys. Highly trained individuals begin with more glycogen, they replenish faster, and they deplete slower. So theoretically, they can train with greater frequency and volume. Now, when are carbohydrates limiting? Okay, when are carbohydrates limiting? Well, here's the thing to sort of understand. If you're racing 60 minutes, you're probably not going to deplete your glycogen stores. Okay, maybe by 30%. But that's not limiting. You got plenty of glycogen left. But if you were to go 150 minutes, then it would be limited. So the duration of the event is very important. The duration is going to determine how limiting glycogen is. And that's going to determine how many carbs you should take in. This is a classic paper by Burke. And basically what they're showing is what happens if you get 2 grams of carbs per kilogram of body weight, 3, 5, 7, and 10 grams. But you notice that 2 grams per kilogram is only increasing maybe 0 to 5 millimolars of glycogen. Remember, think if you had 100 units. So imagine if you have 100 units and you did a hard race and you deplete it by 50 units. How quickly could you replenish? Well, 5 grams of carbs per kilogram of body weight would completely replenish that in 24 hours. Okay? If you had 70% depletion, then 7 grams of carbs per kilogram would replenish that. So based on this, Costel suggested that you should have about 5 to 7 grams of carbs per kilogram per day. So a moderate amount of carbs, particularly in training events lasting less than 90 minutes. Now here's something that's interesting. Basically, they took a 21-kilometer run, which is not a super long run. It takes maybe a little bit more than an hour. And what they did was they had the high carbohydrate condition where they had 3 days of 5 grams per kilogram, and then they loaded for 3 days at 8 grams per kilogram. The moderate group just had 5 grams per kilogram for 6 days. So again, remember this is maybe like an hour and 20-minute run for well-trained guys. Now, notice on the glycogen concentrations, the moderate group began with less glycogen than the high group. However, they ended with the same amount of glycogen. So basically what it's saying is if you glycogen load, then you're going to be more reliant on glycogen as fuel. But performance was no different. They finished in the exact same time. So for races that last less than 90 minutes, it's really not that beneficial. Now, but one thing I want to point out, though, is that when you're consuming carbohydrate, if you rest from one day to the next completely, that's passive resting. However, one thing to consider is that if you train very high intensities, like 80% VO2 max, you can drastically deplete carbohydrates. And unless your diet's drastically high in carbs, then after consecutive days of very high intensity, your glycogen levels will actually keep going down. You're not giving yourself enough time to replenish. So that's where higher carbohydrates might be beneficial. So this study did an overreaching cycle where they essentially had, they started the subjects off and had them perform essentially like a laboratory test. So 30 minutes at 60% VO2 max, 30 minutes at close to 80% VO2 max, and then an 8-kilometer time trial. Then they trained easy for 3 days, 60 minutes a day at 75% heart rate max. Now, I don't know about you, that's not easy for me. And then they had a hard training day. So in the hard training day, that was all-out effort. And notice they had a lot of hard days. So then they had another time trial. Then they had 2 hard days. Then they had another time trial. So this is an overreaching cycle. You don't have time to replenish. Notice here, look at the speed, the high carbohydrate group versus the control group. Basically, early on, like for the first 5 days, there's no difference. But after 5 days, you see a clear difference where the high carb group can maintain higher velocities. So for overreaching or very high frequently trained athletes, they might need to get closer to 8 grams. And then here's basically a study where they're showing the group again that had moderate carbs versus very high carbs. And in this race, it was greater than 90 minutes. So it was 30 kilometers. Notice that the high group actually finished their race faster than the moderate group. So again, in races lasting greater than 90 minutes, it may help to get your carbohydrates up to 8 grams. So essentially, we're going to sum this up. Low-intensity activities are not relying on a high amount of glycogen sources. Exercise continuing for hours without depletion. But moderate to moderately high aerobic exercise, performance is related to starting glycogen stores, and depletion of glycogen is related to exhaustion. So if you were to make recommendations, what would you do? Well, in general, if you're just doing light skill-based aerobic exercise, 3 to 5 grams per kilogram is probably more than enough. You know, at 5 kilograms, you're probably going to replenish 50 millimolars per kilogram of body weight. If you're moderate to high intensity, 60 to 90 minutes, and you're training consecutive days, you know, depending on how hard and how intense you ran, you're going to go 5 to 7 kilograms. You know, maybe 5 on the light days, 7 on the high days. If you're training for 90 minutes to 3 hours, you might need 6 to 10 grams per kilogram. And if you're extreme, moderate to high, greater than 4 hours, you might need 8 to 12 grams per kilogram. So, you know, that's all of these recommendations are basic. Most people are going to fall anywhere from that 5 to 7 gram range. So one of the things to talk about is like pre-event strategies, like carbohydrate loading. So carbohydrate loading, again, was that strategy where they went moderate carbs and then for 3 days super high carbs. So basically what you might do is have your base, 5 to 7 grams of carbs per kilogram, but you're going to follow that up with a high series for maybe 48 hours of 8 to 12 grams per kilogram before the event. This will be beneficial, again, for events lasting longer than 90 minutes, but not less than. There's no point. And again, under passive conditions, if under 90 minutes, 5 to 7 grams per kilogram is fine. However, if not passive, if you're in an overreaching condition, again, you may need 7 or 8 grams per kilogram. And that's sort of everything. Thank you.